So if we looked at these ages, if we're saying the life expectancy from birth, we would find the average age of death for all 10 of these people. So we just want to add these 10 numbers together and then divide by 10. I love it when it's divide by 10 because then I can just use the decimal, move the decimal. So if we add them all together, I came up with 377. Anyone else come up with 377 when you added them?
I must have put mine wrong at 308.
377,
Did anyone else get 377? I want to make sure that I... Okay. So then when I divide by 10, the life expectancy at birth would be 37.7 because we would include all of them, all right? The median age at death, well, we want to be what's right in the middle. There are 10 numbers, so right in the middle would be here between 34 and 46. But okay, does that make sense? You're skipping a step. But if you think the answer is 80...
You divide it by 2, right?
Divide it by 2. Because 80 was like older than any of these people. That wouldn't make sense, right?
So divide that 80 by 2. Okay.
So if there are 2 numbers in the middle, then I'm averaging those 2 numbers. I'm basically finding what's exactly halfway between those numbers.
40.
So that would be 40. So the median age of death is 40.
Okay, so you got to remember to add the 2 numbers and divide it by 2.
Mm-hmm. Now, sometimes you can just see. If it had been 34 and 36, we could just know it's 35. Because that's what would be right between them. Okay? So, how does the mean compare to the median?
How does the mean compare?
So, the mean is over 2 years less than the median. So when you think about life expectancy, like the graph showed life expectancy at different ages, so then if I wanted to figure out just for these 10 people, obviously a very small population size, the life expectancy at age 20, we would still do the average, we would still do the mean, but we would think it would only include people who are survivors at the age of 20. So for this group, that would then include only these last people, these people. Because they survived to age 20.
Okay.
So basically, if you make it to 20, now this is your life expectancy. So we are going to do average again. We're going to add them together. Or, I guess, instead of adding, we could just subtract 23. Why would I say I could subtract 23? I just added the 4, 7, and 12 together. Like I'm just taking those 3 off, basically. Or I could add them. It should get the same number. Are we still dividing by 10? No. How many are we going to divide by? 7. So now we're dividing by 7. So we find out that the average age of death for people who survive to age 20 is 50.6. And then what if it was the average age at death for those to survive to 60? So which numbers are going to be included if we're talking about people who survived to be 60? Yes, just those 2. Good.
63 and 76, right?
Uh-huh.
Add them
Add them and
and divide by 2.
divide by 2. So we should come up with 69.5. And these values would be called life expectancy. Okay, so these average age of death, the average age of death is the life expectancy. So in this group, for people over 60, the average life expectancy was 69.5. So, like, if we look at that chart at the beginning, you see that on the page previous where we had the graph, you see that those things way at the top, they're not changing too much. So once you make it to a certain age, things kind of level out. But the improvements in healthcare and like vaccinations and things like that, medical care, we don't have nearly as many childhood deaths. So as the years have gone by, that from birth number has gotten much closer to those other numbers. So what if there was an error? Okay, so there's an error. I'm going to have to change my zoom because I won't be able to get everything on here. So if there was an error and the 84, it should have been an 84 instead of a 76. For the whole thing, not just for the over 60 people. Okay, for the whole thing, what would the mean age at death be then? So going back to using all 10, but using an 84 instead of a 76.
So 385 divided by 10?
Mm-hmm. Good. So it would just be 8 more, right? So we could add it all together again, or we could just add 8, because that's the difference between the 84 and the 76. So then our mean increases to be 38.5. And remember, for the entire group from birth, it had been 37.5. What about the median? Does the median change when I change that 76 to an 84? No. The median, still 40. So if we have someone, even if we said that oldest person, it was 100, it changes the mean. It affects the mean. In fact, if we put something like 100 in there, it would affect it a lot. But it doesn't change the median. So when we have outliers, things that are far away from the other data, then it may be more appropriate, to use the median instead of the mean, because it kind of skews the data if we have something out there far away. And we'll see some more of that. So this is some show. We'll say, I don't know, maybe it was, I don't want to say Backstreet Boys. I don't know. It was something. Some boy band maybe. So this is at the show. These are the people, the ages of the people at the show. We got a couple 11-year-olds, some 12-year-olds, 13-year-olds, 14, 37, 44, and 50. The mode, remember, is the one that happens the most. So which number here happens the most? 12, right? That's an easy one. So notice there can be more than one mode, but it has to be a tie. Like if there were also 4 13s, we could say 12 and 13. We would not average them. We would just list 2 of them. But in this case, yes, it is just 12. And how about the median? So there are 12 numbers. So between 6 and 7, which would be here. So then what is halfway between 12 and 13? 12.5, exactly. and then find the mean for this data. So there are 12 of them total. So when you're finding the mean, just in case it's not clear, yes, you need to put 4 12s in there and 2 11s. Don't just enter each thing one time. So what did you guys come up with for the mean? Round it to the 10th. Keep 1 decimal place.
20.1.
20.1 is what I had also. So if we were going to plan to sell merchandise to this group of people, oftentimes we think like, oh, well, I should target the average age. Well, in this case, if I use the average, if I use the mean, targeting 20-year-olds would not be very smart, right? So, yeah, 12-year-olds. And one, there are more 12-year-olds than anything else, but also even the median, right, is close to 12. If we target 20-year-olds, there are no 20-year-olds there at all. So using that average, when you've got those people at the high end who are probably parents who had to come with the children, right? That's my guess. These are the parents who had to be chaperones. So yeah, so sometimes it's going to be, one piece of that information or another. Oftentimes they're going to be really close. The median and the mean might be really close. But in a situation like this, the mean has been skewed. We call that, it's been skewed to the right by those big numbers at the right that don't really represent the rest of the data. There we go. It's skewed to the right. There are mostly low values with a few significantly higher values. Those are referred to as outliers. So when we have outliers like that, the median or the mode may be a better measure to look at rather than looking at the mean. So in number 2, you could find the mode just by looking, if you're careful. You could find the mean, but please be sure before you find the median that you put them in order or that you keep track. When I worked through this one, I didn't rewrite, and then I was like, I should have just rewritten. We should find that in this case, it's symmetrical, that the mean, median, and mode should be close to one another. But go ahead and work through this one. Find your mode, your mean, and your median.
Should we rewrite this in ascending order?
I think it's easiest. It's worth the time, especially when it gets to the median. And again, you can have more than one mode if there's a tie for what happens the most. Okay, so since there are 15 numbers, there is a number that is smack dab in the middle. As it turns out with this particular data, if you forgot to put them in order, there is a 4 right in the middle. You would kind of get lucky that it is in the middle. But please don't think that that always works out that way. Usually if you don't put them in order first, you don't end up coming out with the right number. Okay, so the next one we have some exam grades. And these are already in order. 2 people did not take the exam. I always hate, in my grade book, it will give me the mean of the scores. And I always hate to put the zeros in because I want to know how people who actually took the test did. And those zeros obviously are going to affect things. So if we ask for the mode, it would be easy. It would just, 80 and 0, I suppose. But find the mean and median of the scores.
You say find the V and D?
Yeah, I'm just reading the directions. Yep. So for the mean, we know we're going to add them all together. Even though you don't have to put plus 0, but you do have to divide by 8. Yep, you could just go ahead and write that as 55.9. It would be okay if you put 55.875 and listed the whole thing, but 55.9, 1 decimal place, is going to serve us well here. And then the median, since these are in order, 4 and 4, I need to find halfway between my 72 and 75. Yep. Or you might even just be able to look at them and think, what's halfway between? So divide that by 2. If you forget to divide by 2, hopefully if you started to write down 147, you'd go, wait a minute, that does not make sense at all. 73.5. And if you look at that number, is it halfway between 72 and 75?
Yes.
Yes, it is. Okay? So now, which one do you think is a better representation of the average score for people who actually took the test? So if I wanted to think about how did my students do on this test, if I look at 55.9, then I think, wow, everybody bombed this test. People didn't even pass.
Right.
So I would the median would give me a better, and remember the median tells me half the people scored lower, half the people scored higher than that number. Now, those 2 zeros, it still sucks, but the zeros don't affect the median so much. Those 2 zeros could have been in the 50s, and the median would have still been the same. The middle score is still the same. So in this case, as a teacher, the median would tell me a little bit better how my class did, because those zeros, because when I look at it, really I only had one person who took it who did bad, who didn't do well. Well, I had one person who,
55.
yeah, the 55 is the only person who failed the test. But when you see 55.9 as the average, it looks like, wow, man, I suck as a teacher. And it's no, my people aren't showing up to take it. So I think here that the better representation would be the median. How did the 2 zeros affect the mean and the median?
It didn't affect the median.
So it really doesn't affect the median, unless those are people who would have taken the test and gotten over a 60 or something. Now, if those 2 zeros weren't in there at all and nothing else was in there, where would the median have been?
75 and 80.
Between 75 and 80. So it would be a little bit higher, but not tremendous amount, right? So it has a little effect. If we just threw them out, it has a little effect on the median, but it affects the mean much more, right? It affects the mean much more. Okay. This is an example that's skewed to the left. It's skewed to the left because it's those numbers on the left, those low numbers that are far away from the other numbers. Okay, so when it's skewed left, it means that our mean is going to be pulled down lower than what represents most of the data. If you look back on the previous page, you can kind of think of what it says about skewed right compared to skewed left. But it means there are skewed left means there are a few things that are really low. Left is going to be low. A few things that are really low that pull our mean down lower than what actually describes things. So when we look at the graphs, it can be a little misleading, or I don't know about misleading, but a little harder to get our head around, because with the graph, remember that it's the few. The few to one end is what pulls the mean in the opposite direction. It's not where the big things are. So enrollment by age is actually skewed right.
So skewed right or left?
There can be skewed left or right.
And it's the same outcome. The mean is always...
It's the mean that's affected, but if it's skewed right, the mean is going to get bigger than what represents the data.
Right.
So like here, if we toss in some people who are 50, 60 years old, the average age suddenly looks like the average is maybe in the late 20s.
Add them all and divide.
Right? So it looks different. Like when I look at this, I want to say left because I see those tall bars on the left. But the skewing is what happens from those few. Few and skew. Few and skew, those rhyming words. The few to the right skew this to the right. Here, this is balanced. We got some here, we got some here, but the bulk of things is in the middle. When the bulk is in the middle like that, that's, well, not balanced is not what they call it, but symmetric is supposed to be our choice there, not balanced. And then the exam scores, we got these few down here, super low scores that are skewing it to the left. So where there are the few, that's the direction it's skewed if you're looking at the graph. So when it is symmetric, the mean and the median are going to be really close, typically kind of somewhere right in the middle. If it's skewed, though, they're going to get separated because it gets pulled, the mean gets pulled to one side. So if we look at this exam scores, and we're trying to figure out where the median would actually be located. So it is skewed left. We've already said that it's skewed to the left. So the median, which one? First it said,
Would be low.
so the median is going to be kind of what's in the middle. Well, there are so many scores to the right, right? There are, when we look here, we've got 10 of these, or 8, or 9, something like that. I guess that's 9. This one is 9. I can't see that line on the screen very well. There's like 9 of these and 10 of these, 6 of these, 5 of those, 2 of these, 3 of those, 1 of these. Okay? So when you think about how many there are 36 numbers altogether. You follow me? That if I count the frequency, this is the frequency of it happening, there are 36 scores represented here. So if there are 36, the middle would be between number 18 and number 19. Well, there are 19 numbers down here. So the median would actually be in the 80s. Half the people scored less. So there's 11, 16, 17, even one of these would be in the less, and then this would all, but the mean, now we don't have exact numbers here, right? We don't have exact numbers for these things, but the mean is actually going to get pulled down and would actually be like in the 70s, maybe upper 60s even, if we actually tried to do the math. If we were going to try to do the math on that, we would do like the middle of each range, just so if you wanted to know, like, how would I even get a gauge on that? You could do like 9 times 95, 10 times 85, 6 times, like you would just kind of average, like to try to get an average of what's in there.
So when it's skewed left, the median is actually not in the middle?
The median is still in the middle. It's because if I wrote these scores out, when you get the bar graph like that, because this is the frequency, this would be like saying that there are 9 scores that are down here in the 90s. You see what I mean? There are 9 scores that were in the 90s. 3, 6. There are 10 scores in the 80s. So the median, because this is frequency, the median is, but when we average them all together, these low numbers down here is going to pull the mean away from that. And it's not easy to see exactly where it would be, but if it's skewed left, if most of my stuff is to the right, but I've got a few things down here, then it's going to pull it down. So it would probably pull it down into the 70s. Okay, we're going to skip a couple pages and go to the page that says weighted average. And I will be curious to find if any of you kind of use this strategy when you found, so we're going to skip over 2 pages here. Eventually we will do a few things on spreadsheet. If I had all of these quiz scores and I needed to find the mean, okay, I have all these quiz scores, and I needed to find the mean. And some of you might have done this even on the other page where we had some of those lower scores, but there were several 3s and several 4s. So you could 10 plus 10 plus 10 plus 10 plus 10 plus 10. Right? Like you could do that. There's nothing wrong with that. But do you see where this would kind of be a shortcut? Instead of typing 10 plus 10 5 times, or even in your head, you might just go, okay, there's 5 10s, that's 50, right? So that's what's happening here, is they're just grouping them to make it easier. So if I group them together, then I see that there are 5 10s, and there are 5 15s, and there are 10 20s. Now, we do not, it's just 10, 15, and 20. We don't just go 10 plus 15 plus 20 divide by 3, right? Because it matters how many people had each number. So instead of adding them individually, we could do this. And then we're still dividing because there are 20 scores. So we end up with 50 plus 75 plus 200. All divided by 20. So I've got 325 divided by 20. Like 16 and a quarter, 16.25 maybe. Now, the second way that's listed is really not a good way to use for this data. So I'm going to skip it and show you how that works, like if you have a weighted grade book or something. Because it would be way too much work, or at least I feel like, to find out that, there was, 25% of the people got this score. And why would I want to do that? In this case, this is going to be much easier to do that first way. When we divide, we do get 16.25. The other way has to do with percentages. Now, if we are, in my grade book, things are weighted. Quiz points, test points are not the same as homework points. And it's going to depend on your class of how those kind of things work. Or GPA. Okay, now this GPA doesn't have plus and minus, so it's a little different than how our GPA at school here works, but this is a very basic, if you're finding GPA, and it depends because some classes are worth more credits than other classes. So, for instance, when I teach financial foundations, it's a 4 credit hour class. So if someone does poorly in that class, it would affect their GPA more than if it was a class that they're only earning 1 credit. So in this case, these are some Ivy Tech classes. They've got a history, an anatomy and physiology, a lab, and the Ivy 101, which is like an introduction to Ivy Tech. So they're not all weighted the same because the one class probably only meets 1 hour a week. Whereas that anatomy physiology class is a 4-hour meeting plus outside of class. So C's count for 2. It tells us up here. A's are 4. B's are 3. A in this one. And then the credit hours times the grade as a number. This is also called the quality points. All right? They'll call these quality points. So we're doing 3 times 2, 4 times 4, 2 times 3, 1 times 4, and then we add the credit hours. So altogether this person is taking 10 credit hours, and they earned, this would be 32, like we could call them quality points. That's how I've seen them referred to, quality points. And then if I want the GPA, I do the 32 divided by the credit hours. So their GPA is a 3.2. Now, pluses, minuses, now they've attached different points for pluses and minuses. I don't know for sure. My daughter's school, if she took college credit classes, they were considered like advanced, and then like a B in the class got the points of an A. So then like your dual credit classes, like this class, then would count not as more credit hours, but an A in this class would count as a 5, and a B would count as a 4 for your high school, for high school grades. Now, I'd have to look to see exactly how the Excel Center handles that. I know that there are some things above 4, people have above a 4.0, so it's either because of dual credits or because A plus is getting more points. When I was in school, it was just simple. If you hit the 90 and you got an A, you got the 4. Now it's not so simple. It's like not the minus and the plus get different points. But for our purposes, when we look at finding GPA, we'll just be dealing with the 4, 3, 2, 1. And then it matters how many credit hours. So getting an A in your IB 101 doesn't matter nearly as much as that A in the A and P. Okay, so I'm going to make up some classes here. So let's say you have English 4, and it's 2 credit hours as far as the high school credits. And you have Math 123, and it's 2 credit hours, which is always confusing compared to 2 credits. And you have Biology A. Since it's just Biology A, that's only 1 credit. And you wouldn't have Algebra 1 at the same time. So let's say you have History, we'll say U.S. History A, which if it's only A, it's only a 4-week class, but also 1 credit. And let's say you get A's in these 2 classes and B's in these 2 classes. So sometimes people would say, well, I got half A's and B's, So I've got a 3.5. Well, in this case, you would do better than that because you're getting the A's in your classes that are actually earning 2 credits, and you're getting the B's in things you're only earning 1 credit. Now, if you're in U.S. history with Chris and you stay the whole 8 weeks, you do get 2 credits, but just for the purpose of the exercise. So, lots. So A's are 4, B's are 3. So then you're going to multiply the credit hours times the grade. So 2 times 4 is 8. 2 times 4 is 8 again. 1 times 3. 1 times 3. And then we add up the credit hours. Or in this case, we're talking high school, we would just say credits. We add up the credits. We add up the quality points. So I got 16 and 6 makes 22. And then we would be doing 22 divided by 6. We never add up this column. That's why it's great. So like 3.67. 6 forever, right?
Yep.
3.67. Typically, I know I just told you guys like you could just keep 1 decimal place. A lot of times you'll see a GPA round it to 2 places, but 3.7, 3.67. So depending on how many credits a class is worth, Algebra 1, for example, here, Algebra 1, you also get Algebra Enrichment credits. So that 1 8-week class is altogether 4 credits. So for those of you who got like an A+ in there, that boosted your GPA. If you're doing your PE credit on Odyssey Ware, it's just 1 credit. I mean, still do your best, but it's not going to affect your GPA as much.
You don't know how happy I'm here to hear that because I just got a really upsetting grade with my Odyssey Ware last week or last night.
Yeah, sometimes it does kind of suck because I see that people got like B's in Odyssey Ware, and not that B is horrible by any means.
It's not horrible.
It's not horrible, but when all your in-class grades are A's, it's like disappointing.
Exactly.
Yes.
I got to see him out of school econ. It's hard though.
Yeah. But you're like, but it's done. I mean, at some point it's done.
So.
Well, the thing with Odyssey Ware is that it almost punishes you for doing good because you'll do really good in the pre-test and then it takes away those assignments, and then on the final test, those assignments will be there. You're like, well, I haven't looked at this for a while. Yeah, it's like it makes it shorter, but it doesn't make it easier by the end. I get what you're saying there. Wow. So here is another thing that happens, and this is I have to weight my grade book for this class. I'd have to look again to see how it has to be weighted because it's different than my usual classes. My usual classes are 60% of your grade is based on your test, 20% for all the homework, and 20% if you have a final exam. Okay? So then sometimes people get really hung up on the homework, and I'm like, I want you to do the homework, but the big thing is that you can do the test because that is weighted more heavily. So we're going to look here. This is the weighting. This weighting should always add up to 100%. If it doesn't add up to 100%, then something's like they don't have the whole grade accounted for. So if we want to find the weighting here for the categories, so if your average on test is 85 and you have 100% on your homework, notice when we do the category average, we're going to leave the percents off. We're just going to write the score. And 85% on quizzes. So then you take your 60% for test. So 60% times 85. Personally, I would over here go ahead and write 0.6 times 85. You could do a proportion also if you want, but just changing it to a decimal.
25% times this one. So 60% times that 85, or 0.60 times 85, gets us 51. 15% of the 100, 15. 25% of 85, I think that's like 21 point, 25%. I think that's 21.25. Now if we add that all together, add these numbers that we just got, add them together, 66, 80. So I get 87.25. That's the final grade. The 87.25.
What you divide that by?
I don't divide it by anything.
So I get 87.
How did I get 87?
Yeah.
I added 51 plus 15 plus 21.25. So if you understand how those things work and you're in a class that's weighted, then you can kind of figure out where your grade is going into a final exam. I've had lots of times that then I'm like, okay, all I need is a C on the final exam and I keep my A. But you have to understand how the weighting part of it, weighting as in E-I-G-H-T instead of A-I-T-I-N-G, works out. So when we have these percentage weights, there is not a division step. And the total of the weights should be 100%. So as far as question 2, no division step, and the total of the weights should be 100%. So now, same class, and the average on the test is 85%. And the homework average is still 100, but the quiz average drops to 25% for quizzes. Just not ready for those pop quizzes, I guess. Now, because some of these are the same as they were before, we can use those numbers that we had up top. We don't necessarily have to recreate the wheel. So we already did 60%, which is 0.6 or 0.60 times 85. We already found that once. That was 51. We're still earning all those points. We still have our 15% of 100. That's not changing. But now those quiz grades, I'm struggling. So now on quizzes, now I've only earned 6.25. We add these together. Remember, we're adding, the decimals would be like over here. So the 6, it's like adding $51, $15, and then $6.25. So 72.25. Is it only 62? No, I think it's 72. 51 plus 15 is 66 by itself. So 72.25. So they're a little uh-oh over here. I mean, it's still like a C, C minus maybe. But things just took a nosedive.
It wouldn't have been as bad if he was 25% of the homework.
Right. If he was going to slack on something, the homework would be what hurt him less. Okay, so for this next one, we have several different lab report grades, and the lab reports all together are 20% of the grade. The quizzes are 20% of the grade. The midterm is weighted at 30%, and the final is 30%. So we have multiple lab reports and multiple quizzes. How do you think we could deal with those?
You can find the, some top of my tongue.
Yeah, how about if we add these together and find like the average, find the mean. Find the mean of the lab reports. We cannot do 20% of every one of those and add them in. Because that would be too much. Okay? So it's 20% of all of the lab reports. So we need to add them together first, find their mean, and the same with the quizzes. So we'll add them together. You don't need to worry so much about the percent sign. Just worry about adding the numbers. We've got 5 lab reports, so we can add them together and divide by 5. And then for your quizzes, same thing, add them together, divide by 4. That'll give you a mean and average there for your quizzes. Okay, find the mean. You told me at the beginning today you knew how to find the mean, right? You add them together and divide. So add across that top row. Then divide it by 5. And then we can do what we did on the other page. So using the averages. And then the ones that, if they only have 1, then that is the average for that. So after you have, hopefully we all got 77 for our average lab report score and 78.5 for our quizzes. And then I'm using, so 20% is the same as 0.20, but the 0, I don't have to use that. I can just use 0.2. So then I'm doing my weighting. That's my 20% of 77. That's my 20% of my quizzes. Then it's 30% of the midterm. That's where the grade comes from. And 30% for the final. Which we can probably all look and see that 54 on the final is not
very good.
no bueno. Not good at all. And then after you have these 4, what are we going to do after we get all 4 of them? Add them up. Exactly. Nope, we do not divide by 4. We're just going to add them up, period. Because the first one is 20% of the grade, 20% of the grade. It adds up to 100% of the grade. So there is no dividing after we're doing our percentage weighting here. The dividing is kind of happening because we've got the decimals. And I didn't write down my in-between steps for the rest of this. I just wrote down, I ended up typing that all in my calculator. I don't think this and this can be the same. Because this is 0.2 times 77. This is 0.2 times 78.5, so it has to be bigger. Yep.
Groovy.
Okay, so this could be, so when we talk about weighted averages, it could be with a percent Or it could be something like when we have like 10 scores of this, 5 of this, 5 of this. When we have the so many numbers of each one, we do have to divide at the end. Because it's just a shortcut, basically. And here, when they're saying that they're then in number 2, and I guess that would have a percent sign. So instead of just adding together their different prices, you would want to do like their average meal, thinking of how many times they sell their $5 tacos. So we'd have 60 times 5 plus 32 times 7 plus 24 times 8. Do you guys come out okay with the top part?
7.1.
Yep, that's what I got. And personally, I just left everything in my calculator. And I don't know that I don't think we had a bunch of decimal places anyway. And yep, and so then you're going to multiply those, add them all together,
Okay.
and then you will have a division step. What are you going to divide by at the end? Not going to divide by 3. How many total meals did they sell? So I'd have to add all those numbers together. If I would only divide by 3, I would have like some crazy ridiculous number that their meals cost an average of like $300 a piece or something.
A little shaky,
That's why we're practicing. If you turn 1, 2, 3 pages front and back, you'll get to section 6 assignments. There are 2 pages total.